All right, so welcome everyone to this training session on Azure Data Engineering. And today, on day one, we are going to start with the basics of Azure. All right, so I am assuming that most of you have no prior experience in Azure, you've not worked with Azure, yes, you do not know the basics of Azure. So our initial first few days are going to be focused on what Azure is, how it is built, what services does it offer, and what are the basic requirements that you should know about Azure in order to advance to the data engineering services which are present in Azure. So to use services like Azure Synapse Analytics, Azure Data Factory, Azure Databricks, Azure Stream Analytics, Azure Data Lake, you should have some basic understanding of the platform itself, of what this platform is, what all does it have to offer, and how does it do it. All right, so that is going to be our discussion or the core discussion that we're going to have in the first few days, where we'll see what Azure is, how it is built, yes, what are the basic concepts of cloud, and then what services does it offer, right? Starting from compute services like virtual machines, app service, to networking services like a virtual network, express route, firewall, yes, to database services where it offers databases like Cosmos DB, Azure SQL, all right. And then storage services where we'll see the storage account and the data lake and what is the difference between the two. So let's not waste any more time and begin. Just give me a second. All right. So our entire discussion, we'll start with what cloud computing basically means. All right. So I don't know if you're aware of it. Yes. I don't know if you work with cloud computing, you know what cloud basically means. All right. But in the simplest of terms, cloud computing basically means that you are getting resources, all right? You are getting on-demand access to resources over the internet, all right? So your resources that in real life or in general terms, you would need physical hardwares for, or you might need to go somewhere to get them. Yes, you need to procure those resources, and it would take a long time. It would take a long period where you might have to go to markets to buy a storage device or to buy a compute machine, or let's say place an order on Amazon or Flipkart, and then it is getting delivered in 1 or 2 days or 5 days. So all those resources, and there are a lot. Yes, on your screen, you would be able to see compute resources. So a compute resource is any resource that contains CPU and RAM. All right. Any resource that requires compute or any resource that requires CPU along with RAM is a compute resources. So the most common example of a compute resource is a virtual machine. Yes. So let's say you have a requirement where you want to, uh, train your AI model. You're working with AI and the model needs to be trained. And for that, you need a very high-end PC. All right. When I say high-end PC, basically the specifications. Let's say you want 16 cores or 32 cores of CPU, 128 GB of RAM, but you don't have a machine like that. You don't have a machine that is capable of, taking that amount of workload. So what you'll do, you have two options, either to get a machine that has those capabilities, yes, which is obviously an expensive process because you might need to go to the market or you might need to, place an order online where you're buying that machine. And when you buy something, it's expensive, right? It's going to cost you a lot of money to get a machine with those high specifications. But just imagine if there was an option to rent this machine for a couple of days. Let's say you only want this machine for 24 hours. So if I tell you that you have a cheaper alternative available, the rent is super cheap and you get this machine, right, for 24 hours and you only pay for 24 hours. Even if you want it for 5 hours, you end up paying only for 5 hours. You don't have to pay for the entire day. All right. So that is what cloud computing brings to the picture. right? It eliminates these steps of procuring hardware, managing hardware, right? Because if you're using cloud computing, if I provision this virtual machine from, let's say, Azure or AWS or GCP or any other cloud platform, if I'm getting this machine from those cloud platforms, I am not responsible to manage the hardware, to do the maintenance of the hardware. The hardware portion of it completely will be managed and maintained and taken care of by the CSP. In cloud computing, CSP stands for cloud service provider. All right. So for example, if it is Azure cloud, then Microsoft is the cloud service provider. If it's AWS, Amazon is the cloud service provider. For GCP, Google is the cloud service provider. So the cloud service provider is responsible to take care of any issues, any maintenance, any management, any upgradation of hardware. Yes, all of it is taken care of by the CSP. Now, your requirement there is just to go to a portal over the internet, right? You have portal for GCP where you can go and provision resources. In GCP, you have an online portal for AWS where you can go and provision these resources, or you can go to Azure portal. Now, once you go to these portals, you have to select what resource you want. Let's say to train my model, I need a high-end machine, which basically means I want a virtual machine on the cloud. All right. A virtual machine is a replication of your PCs, of your laptops, of your machines on the cloud. It's exactly the same thing. What do you want to describe or what do you want to configure when you're creating a virtual machine? You need to specify what is the OS going to be? Yes, whether I want a Windows machine or I want a Linux machine. As of now, Mac machines are not supported. All right, you don't get iOS virtual machines. All right, you only get Windows and you get Linux, and you have various versions of Windows and Linux. All right, you get Windows 10, you get Windows 11, you get Windows 11 Server Edition, Windows 10 Server Edition, and there are a whole lot of variations of the operating system that you can select from. When it comes to Linux, you have all sorts of different Linux types available. So you can select any one of them. And when you select it, let's say you want to create a Windows virtual machine. You select Windows. Yes, you select the edition of Windows that you want, Windows 10, Windows 11, Server Edition, whatever you want. Then you go ahead and do some more configuration related to the security of the virtual machine. Let's say creating the username and password. Yes, when you log into your Windows machine, you need to enter a username or you need to select a username and enter a password for it. That is what you will have to do here as well. And then you select the size. Now, when I say size, it basically means how much CPU you want, how much RAM you want. And along with that, you can also configure storage for your virtual machine, right? So it comes by with a default storage. Every window virtual machine size will come with a default storage. It's generally 128 GB, right? But obviously, if you want to extend it, if you want to add more storage, you can do that. Now, coming back to your own environment, let's say where you have your own machine, and our example was that you want to train your AI model, right? Now, let's say that to train that model, you have huge amounts of data, right? You have at least, you know, 3 or 4, 5 terabytes of data, let's say, for example. Now, your machine is only capable of, let's say, your personal machine has only 1 terabyte of storage available, right? Most of it will be used, or some of it will be used, so you will not even have one entire terabyte to put your data into it. So now again, the alternate solution for this is that you get a storage device for your machine, right? Or you increase the storage, you scale up the storage of your machine, or you can do that on your virtual machine with just a click of a button. All right. If I want to increase the storage of my existing personal machine, it's a long, tedious task. But if I want to do it for my virtual machine on the cloud, it's just a matter of minutes. Within 1 or 2 minutes, you'll be able to add more storage. All right. So that is the benefit of cloud computing, where you get on-demand access of resources. I wanted a virtual machine, I got it within 5 minutes. There is zero human interaction. I do not have to go and talk to anybody. I do not have to ask anybody. I just need access to the Azure portal. I just need a subscription. What a subscription is, we'll discuss later on, but you just need a subscription. If you have a valid subscription, if you have an active subscription, you're free to go ahead and create these resources, right? To store your training data, you can create a storage resources also, all right? So all of these resources you can create on the cloud, that is going to allow you with faster innovation, flexible resources, economies of scale. Yes. So when you scale your systems or environments in cloud, it's very cheap. All right. And I'll be showing you the difference between, having an on-premise environment. When I say on-premise, basically your own environment versus having your entire infrastructure on the cloud. There are certain calculators created by Microsoft themselves, which will let you compare, all right, or let you have a comparative analysis of what is the difference going to be if I have my workload present on the cloud versus if I have my workload present in my own data center, if I want to build my own data center. Clear? Moving on, before cloud became popular, all right, before the advent of cloud, or before any of these CSPs were offering these services online over the internet, companies still had their data centers, all right, or companies still had their resources, right? They still needed servers, they still needed storage solutions. And how did those companies meet their requirements? Because there was no cloud. I could not ask Azure to give me these many servers, or I cannot ask Azure to give me a storage device. So what do I have to do? I have to buy my own hardware, right? I need to invest money into my own hardware. I need to procure the servers. I need to get the storage devices. I need to build the data center. And building the data center is a very expensive process. It's not an easy task. It's super expensive. All right. So before cloud came into the picture, organizations would create something called as a private cloud, which is nothing but a data center. Yes, you would have heard that inside the office campuses, there were data centers that belongs to these companies. Yes, whether it's Infosys, TCS, Wipro, any company. These companies had their own data centers inside their organization, right? These data centers were only accessible to these data centers were only accessible to the employees. It was not open for general public to be able to access these data centers. Only employees of the organization, yes, whichever organization it was, their employees could access the data center. Their employees could, create resources on in this data center. They could store their data in these data centers, right? So this is called as a private cloud. All right. Here, the organization is responsible for any management or any maintenance work that has to be done, or any management work that has to be done. The organization has to take care of it. They need to have experts, administrators who would be taking care of their data center for them. All right. Now, this meant that organizations now had to pay a huge amount of money to build a data center. Yes. And with the time, when their requirements increased, when their demand increased, they would have to scale their data centers as well. All right. But with limited space available, with limited capacity, there's only a certain limit to which they could scale. All right. It was not indefinite scaling. They could not do that. If they want to do that, they need to build another data center. Yes. But inside their data center, they could only scale up to a limit. All right. So this meant that the organization had to put a lot of money into building these data centers, these private clouds, all right, or private data centers inside their own campuses, in where they would either rent a building or they would build a building. Inside the building, they would set up the servers, the hardwares, the cooling system, the network infrastructure. Everything had to be planned, implemented, maintained by the organization themselves. Then came something called as a public cloud, all right? And there, that is when cloud was born, all right? Now, how cloud was born, it's an interesting story. I think we had a discussion uh, last time as well on it, but just quickly, I'll tell you. Now, the time was around 2010. So this is when cloud was, cloud was born, I would say, or the concept of cloud computing was coming into the picture, all right? Where people now believed that, they don't have to build these data centers on their own, all right? They could be renting out these data centers from the CSPs. Now, what happened was, let's say one of the CSPs, they built a large data center, right? Let's say they had 10,000 servers here, right? They realize that they're not going to use more than 10% of it. That is their only requirement. 90% of it is sitting idle and not being used. So what they decided, let's rent this out. Let's give this out on rent. Why? Because to build this 90%, I have done a lot of investment. All right. And for any investment, anyone would want a return. Yes. Sitting idle was generating no return. Yes, either you use it, that is a return in itself, that it is being used by your organization, uh, that is a return. But sitting idle is not a return. So what do you do? Similar to your house, when you have multiple floors in your house and some of it is empty. Yes, let's say the second and the third floor, nobody's using the ground, and the first is where you're living and your family is living. What do you do? Since you put in money into those second and third floor, you want some return out of it, right? So you give it out on rent. Similarly, these cloud service providers, they decided, let's give this out on rent. The rent is going to be on an hourly basis. Yes, it's very cheap, all right? Very cheap. You pay rent on an hourly basis, and we give you access to these resources. But this transaction or this provisioning of resources and accessing of resources will happen over the internet. We are not going to allow you to come and sit inside our offices and able to access this area. We are going to give you access over the internet. Nobody can come and visit the data center, touch the servers, or just have access to the data centers. That is not allowed. If you want to access your resources, do it over the internet. All right. And then what happened? Slowly, organizations starting, they started having their infrastructure moved over the internet on this cloud. All right. And that process is called as migration. You would have heard of migration a lot. All of you would have heard of, you know, uh, migrating my workload to cloud, migration to Azure. Yes, migrating your on-premise databases, your storage, your servers to Azure. And that is the process where now companies don't want the headache of, managing and maintaining these physical hardwares, physical servers. They don't want that. They want the CSPs to do it for them, and they want to just access these resources over the internet. And that is why there is a boom in cloud computing. All right, everybody is talking about cloud computing. All right, just give me a minute. Now, this is where the concept of public cloud was born. All right, this is the exact definition of how public cloud works. Basically, a CSP will build a data center in any location, in any geographical location, but there are, certain aspects to it as to how they decide in which geographical location I want to build my data center. There are a lot of aspects around it, right? For example, you might not see a lot of data centers in Africa or South America, all right? And the reason is pretty straightforward. Why we do not see these data centers in those regions is because they don't have a huge IT infrastructure in place, right? For example, India. In India, we already have three data centers, and I think there is another upcoming data center. And I'm just talking about Azure. I'm not even talking about GCP and AWS. All right. When it comes to Azure, Azure already has three big data centers in India. There is a data center in South, which is in Chennai, which is called as India South. There is a data center in Mumbai called India West, and there is a data center in Pune as well called India Central. All right, so these three data centers are already there. I think there is one upcoming in the north somewhere, right? Maybe Noida or somewhere. So why is Azure investing so much money into building all these data centers in India? Because building one data center is a very expensive process, all right? Because those hardwares are not cheap. It's very expensive. So why is Azure putting in so much effort to build these data centers? Because there is a huge demand. There's a huge demand or a huge market, I would say, in India for cloud computing requirements, right? People now want to use cloud computing. Organizations, legacy organizations that heavily relied, organizations like Wipro, TCS, Infosys, these organizations, Accenture, who heavily relied on their own data centers previously, are now moving towards the cloud. They're developing solutions based on cloud. All right. They're migrating their existing workload to the cloud. And they're also helping, these service companies are also helping other organizations to move their workloads to the cloud, right? Because eventually everybody wants to move to the cloud. All right. So that is there. In public cloud, the organization would, only pay this rent, nothing else. When I'm using Azure, I don't have to pay salaries for Azure employees. I don't have to pay the electricity bill of a data center. Yes, I have no other payments to make. I only pay the rent. Then, in exchange of this rent, I get these services. It could be any service. It could be virtual machine. It could be an app service. It could be Azure function. It could be a database. It could be a storage account. Any service I want, right? In exchange for the rent that I'm going to pay for it, right? So this is what public cloud was. This is owned by cloud service providers. Yes, it provides resources and services to multiple organizations and users. So basically, what happens is you would have heard of a word called tenant. Yes, when you start talking about cloud, there is a word very famously used, tenant. Yes, and this is one of the most confusing words when it comes to cloud. I don't know how many of you heard it before, but they would be like, it's on my tenant, it's on, uh, you know, some company's tenant. What does this mean? What is a tenant in Azure? So if this is Azure's data center, yes, there is a specific space reserved for an organization. The moment an organization starts creating its resources, there is a specific space that gets reserved for that organization. And that space is called that organization's tenant on Azure. The space that an organization takes inside the data center. For example, there is a building. Yes. Inside that building, you will have multiple floors. Yes. In these multiple floors, you will have multiple apartments, right? So let's say apartment one, two, three, four, five, six, like this. You will have multiple apartments, right? Now, each apartment belongs to a single family or a person or a group of users, let's say. And this is the visual representation of a tenant in Azure. All right. One does not interfere in two's life, two does not interfere in one's life. And so organization one, if their tenant is here, organization two's tenant is here, they do not interfere with each other. They carry their own work in their own way, in their own style. All right. So that is there. You can access public cloud resources over the internet. Yes, it's a secure connection. There is all sort of security available, encrypted connection that you establish. So that is public cloud. Now, there is one more cloud called a hybrid cloud. Now, hybrid cloud basically means that you have both public cloud and private cloud in place. Yes. Now, can you tell me what type of an organization would be using both? Any example of an organization that would be using both of them?
Yeah, the organization which is already having private cloud and they want to extend, they don't want to extend their private cloud and they will adopt public cloud. So those
Absolutely correct.
organizations will use
Absolutely
hybrid.
correct. Yes. Any organization that already has a private cloud infrastructure in place. Now, if they want to use public cloud, they're not going to just remove or stop their private cloud infrastructure. They're not going to do that because they put in a lot of money into it. Private cloud is not cheap. It's very expensive to build. Yes, so they put in the money and they would want to use it, but now they don't want to scale it, right? Because scaling your resources to the public cloud versus scaling your resources in your private cloud are two different levels of costs. All right. When we see the pricing calculators or the total cost of ownership calculator, that is where you will see yourself as to how different it is to extend my resources in my own environment versus extending my resources on the cloud. It's very cheap, very, you get a lot of features, you get a lot of benefits, right? For example, let's say you have your own data center where you have multiple servers, you have storage devices and all, everything is there. Also, you have, let's say, a cloud environment for your organization. Let's say you have both the environments, you're working in a hybrid cloud. When it comes to cloud, you don't need dedicated people to be, going around each server, checking the health, then, troubleshooting, anything that goes wrong into your data center. You don't need to do that with public cloud. That level of management and maintenance is not required because cloud will have various services that will do it for you. For example, Azure Monitor. What does it do? It will monitor each and every resource which is there. And in a central dashboard, it will show you the health, the utilization, the logs, everything related to a resource. What all has happened with that resource, anybody who tried to access that resource, that log will also get created in the Azure Monitor. Yes, the health of that resource, how much utilization is there, CPU utilization, RAM utilization, storage utilization, all of that you will get through these services themselves. You don't need a dedicated person to be monitoring them, right? The service Azure Monitor itself will monitor all your resources. And then you can have somebody, a cloud administrator or a cloud engineer, who would want to take decisions based on the outputs that Azure Monitor gives. All right. So for example, some resources are not working properly, then you will have some remediation uh, planned for that particular scenario. So hybrid cloud is where people already have private cloud, but now they don't want to use it. They want to extend their services on the public cloud, right? So you would have heard earlier companies used to have on-premise Active Directory, but if you see now, everybody's using Azure Active Directory, right? So from on-premise AD, which is your Active Directory, to Azure Active Directory, right? To a completely cloud-based service, from a completely on-premise based service to a completely cloud-based service. That is what is being used now. So I think we also discussed which one is going to be the most expensive cloud. So can you tell me which cloud out of these three that we've seen is the most expensive cloud according to you? All right, so I think we need to discuss the cost part of it. So with cloud, we have three different types of costs. Yes. One is your, let's say, we call it CapEx. CapEx stands for capital expenditure. Capital expenditure is the initial investment that you do. Initial investment basically means when you are creating a data center, all right? When you're building a data center, there's a lot of money that you need to put in to buy the servers, to buy the storage devices, yes, to get the network infrastructure built, to get the cooling system in place. You need to spend a lot of money initially, right? Let's say you don't have a building, so you have to build a building, a data center building. That is also a capex. Second is something that we call as a opex or an operational expenditure. This is capital expenditure. This is operational expenditure. All right. So OPEX basically stands for the amount or the money that you're spending or that you're going to spend in the general day-to-day or a recurring basis. All right. For example, internet bills. You're going to get them every month. Yes, this is going to be a recurring payment. Every month you have to pay for the internet. The electricity bill. Yes, the salary to the employees who are going to take care of that data center. Yes, so that is your operational expenditure. The third type is basically the rent. This is something that you pay in the public cloud. Yes, because in public cloud, I don't have to pay. When I'm using Azure services, I do not pay for the internet cost or the electricity cost or the salary of employees or to build the data center. I don't pay all that. I just pay rent. So this is rent is specific to public cloud only. So now, if I want to see that I have, I have CapEx, I have OpEx, and I have rent. And here I have my public, private, and hybrid cloud. So in my public cloud, I don't have to pay any capex, all right? Because I'm using Azure or AWS or GCP. So I'm not going to give them money to build data centers, right? Similarly, I'm not going to pay any OpEx also. Why? Because I am not responsible when I'm using Azure, I'm not responsible for them to pay their electricity bills, to pay their salaries. I just have to give them the rent. Yes. This is the only thing that I have to pay. When it comes to private cloud, yes, I have to build my data center. Therefore, there will be capex. I need to run my data center. There will be operational expenditure also, but I don't have to pay any rent here, right? Because I have the data center, it belongs to me. To use it, I don't have to pay any rent. When it comes to the hybrid model, where you have private and public both, if I just add these two, yes, so I have to pay rent here, I have to pay capex here, I have to pay capex here, and I have to pay rent also here because I am taking use of both the environments. So that makes hybrid clouds as the most expensive cloud. All right, this makes the hybrid cloud as the most expensive cloud, which is there. So this is the three types of cloud, or we call them cloud models. All right, private cloud, your on-premise environment, considered to be the most secure one. That is why these organizations who are focusing on security, privacy, yes, or banking organizations, research organizations, they generally do not have access to public cloud. They try to create their own private cloud, give access to only their employees, and work with it. All right, they don't want to store this data on a public platform. All right, then you have the public cloud where you will be using resources by cloud service providers, and then you have hybrid cloud, which is a mix of both of them. Then you have something called as cloud services. All right. Cloud computing services are commonly categorized into several models that you would have heard of. All right. There is something called as infrastructure as a service. Yes. There is something called as a platform as a service. And there is something called as a software as a service. Yes. And then nowadays we are also hearing another type of service, which is infrastructure as a code. All right, but that is a completely different thing. But you would have heard of it, IaaC or SaaS, SaaS platform, platform, IaaS platform. Yes. So what are these different platforms? What level of access do you get? What all do you get to manage? The entire differentiation between these services, removing infrastructure as a code, is based on the level of access that you get. All right. So when I say level of access, we already know. So from now onwards in this course, we are not going to talk about private cloud at all. Our entire discussion is going to be public cloud specific. All right. Until and unless we mention it specifically, our discussion will focus on public cloud only. So now what I'm trying to tell you here is when you are working with public cloud, one thing is for sure, the hardware part of it will be managed, maintained, taken care of by the CSP. You don't have to do anything with respect to the hardware. You're not responsible to take care of the hardware, right? When hardware is taken care of by the cloud service provider, what comes on the top is the software layer. Yes, the software layer in the outermost will have your operating system. Yes, on top of the hardware layer, the first thing that will come is the operating system. Under operating system, you will be installing apps. Yes, you might be developing some code and you might be storing some data. Right? Let me write it clearly over here. So you will have access to operating system. You will under operating system, you will have applications. Inside those applications, you might be writing your own code and then storing your own data that code may have generated or you want to store. The entire difference between infrastructure as a service, platform as a service, and software as a service is going to depend on what level of access do you have in this hierarchy. If I have access to all of them, OS, application, code, data, it is called as infrastructure as a service, which basically means you have access to the entire infrastructure. For example, a virtual machine is an example of infrastructure as a service, right? Now, the reason why a virtual machine is an example of infrastructure as a service is because for a virtual machine, I decide the operating system. It's in my hands to decide what operating system I want. Now, just the decision of operating system does not make it infrastructure as a code, all right? Because you have another service in Azure called app service. App service is used to host web applications. All right. So if you want to host web application, there is a service called app service that will help you end to end with hosting, with management, monitoring, everything for your web application. App service, while you are deploying your application, will also give you an option as to what server you want, whether you want to deploy it on a Windows machine or a Windows environment or a Linux environment. So that level of choice also you get there, right? But that does not make app service infrastructure as a service offering. It will be a platform as a service offering. I'm telling you right now, we'll discuss it later also. Then what makes a virtual machine infrastructure as a service, but app service a platform as a service, where in both the cases, I decide I get to decide the operating system. The difference lies between whether you are able to manage the operating system or not. All right. With virtual machine, you get to manage the operating system. Any update, any update which is there, operating system, OS update, anything, it has to be done by the user in a virtual machine. I will show you the moment I create a VM, I will go to the update section and I'll show you that the updates are available, but it is me who has to make those updates, all right, or run those updates, all right. But when it comes to app service, if there is any update in the OS, CSP will implement it from the backend. It is the role of the CSP. So they're giving you a decision when it comes to what operating system you want, but they're not giving you the access to manage the operating system. All right. That level of access you get in a virtual machine. So we say that the entire infrastructure above the hardware layer, if you have control over it, we call it infrastructure as a service. Right. So this is the level of access that you get in infrastructure as a service. If I take away access to operating system and access to install any application that you want, right? For example, when I say application here, you get to manage application. What I'm trying to say is that you get to install, uninstall, update applications in infrastructure as service, right? Because if you think for a virtual machine, you have an option, right? With which application you want to install, which application you want to update, which application you want to remove. You get to manage that layer, right? When operating system is taken away from you and the ability to install and uninstall upgrade application is taken away from you, and you are given an environment, all right, you are given an environment where these applications are pre-installed and you just have to write your code and deal with the data. This is called as platform as a service. For any platform as a service offering, you don't have to, manage the application. You don't have to manage any updates of the application. All you have to do is they'll give you an environment. You just have to, let's say, for example, app service. App service is a platform as a service offering, right? With app service, I can create my web application. Yes. But when you're defining or when you're creating an app service, you have to define which environment you want, whether it's going to be a Python based application, Java based application, JavaScript, Node based application. So you select the environment, it will configure the environment for you, it will install the necessary dependencies for you. But then again, you are not supposed to deal with the application. You just have to write your code and deal with the data that your code is generating. That is it. So that is platform as a service offering where you don't have access to operating system at all. You don't have access to manage applications. You just have to write your code, right? For example, database. What is the database example of? Database is also platform as a service. With a database like Azure SQL, I don't manage the operating system. I don't get to install any application for my database, right? But what do I get here? I get the ability to write code, which is my query. I get ability to deal with the data which is present inside my database. All right. So that makes it a platform as a service offering. Then there are certain developers who don't want to write code. Yes. A lot of people, they don't like to write code. They don't like developing applications. That is totally fine. There's nothing wrong with that. If you're not into coding, if you don't want to code, it's absolutely fine. Perfect. Right. But for those people, we need to create solutions. Right. And not just for those people, for general public also, we need to create solutions. Right. Solutions in terms of what solutions are we talking about here? So solutions based on, let's say, if I want to send an email, I want an application that will help me to do that, right? So to send an email, you have various applications that will help you to do that, like Gmail will let you send emails, Outlook will let you send emails, and there are several other applications, right, which will let you send emails. For let's say we want to conduct this meeting, this class, There are several applications available. I don't have to develop an application where I'll be conducting this meeting. I can use Microsoft's Team, I can use Google Meet, I can use Zoom to conduct meeting. So software as a service basically refers to the concept where you have ready to use services available. You don't have to write any code. You don't have to deal with the operating system. You don't have to deal with any application. All you have to do is utilize, all right, or consume these resources or consume these services. If I want to store data, I am not going to build my own solution where I can store data. I can use a OneDrive, I can use Google Drive. That is it. Those are software as a solution offerings. So with software as a solution offerings, there is not much of a development work that goes into it. There's not much of operating system management and maintenance that goes into it. The only thing that you have to worry about is to deal with your data, right? Because you get only this level of access with software as a service. So when I say data, it basically means that if I'm sending an email, I am sending data. If I'm storing something on OneDrive, I'm storing data. Yes. So with software as service offerings, you just have to provide data, nothing else, and they'll work for you. All right. So this is for people who don't want to code, who don't want to develop application. So we have these ready to use applications available for them so that they can use it, yes, for their own purposes. So these are the three types of services. One is where you get entire infrastructure, do whatever you want. Second, you get an environment, develop. Third, these are ready to use services hosted on the cloud. Just use them, make your lives easy. That is it. So these three are the different types of cloud services which are present.
So Shreyas, as a infrastructure as a service, it means we can define our own operating system, right?
No, you're not going to define your own operating system. You're going to select one of the available operating systems that the CSP has to offer.
Okay. So we have to select whatever the options available to us, like what operating
Yes,
system available to us, what
we'll
application available to us. It is not like that whatever the application I want to do, I can install it. Not like this.
no, inside a VM you can do that. I'm saying the support for different operating systems which is there, it is only limited to a number of operating systems. I'm not saying there are few, there are many, but then
Mhm.
those are the operating systems that you have to choose from. Inside the VM, once you have a Windows machine, then you want to install anything, you can go ahead and do that. All
Okay.
right.
Anything.
All right, it's like renting a hardware in the data center where you are responsible for managing the OS, the middleware, and the applications. Everything you manage. All right. So there's one more thing that I want to discuss with you before we end the class today. We'll stop here. We'll keep our discussion limited to the cloud models and the cloud services. And tomorrow we'll see the Azure architecture, right? When I talk about Azure architecture, basically how Azure is built, what a data center inside in Azure will look like, what are the racks, right? How do you have servers on the rack, and what are the official names or the names given to racks and servers in Azure? They're not called racks and servers; they're called fault domains and update domains. Why do they have that name? Yes. What are the different architecture? What does Azure do to increase availability? Yes. What is availability? All of that discussion we'll have tomorrow. Now, the extra thing that I wanted to show you, just give me a second, is basically the labs. All right. I'm not sure if I have shown you how you're going to access the labs or what all labs are available to you. So just give me a minute and I'll show you uh, what labs are there and how you're going to use them. Just give me a minute. All right. So these are the Microsoft labs that we are talking about. Yes. And each one of you will get an instance of it, right? For example, 4507 is one instance of it. Here you have a lot of options available. All right. So there are 22 labs in total. Yes. For DP203, that is Azure Data Engineer. Yes. Hands-on lab. You have labs on Synapse. You have serverless SQL inside Synapse. Transform data with SQL. right? So each lab comes with a 2 hour duration, yes, and 10 attempts. All right, so 10 of 10 launch attempts remaining. Each lab will give you 10 launches for 2 hours each. That means each lab could be practiced for 20 hours. All right, you can launch this lab 10 times, and each time you launch it, you get 2 hours to practice it, to configure the environment, and start working on the lab. Transform data with SQL, then Lake database, Synapse, Spark, the Spark pool in Azure Synapse, then transform with Spark, Spark Delta Lake feature, yes. Data warehouse, how do you create it? This is a dedicated SQL pool data warehouse. Load data into the data warehouse, then creating pipelines in Synapse, adding notebooks in the pipeline, yes. Then working with Synapse and Cosmos DB, working with Synapse and SQL, then labs on stream analytics, yes. Working with stream analytics and Synapse together, working with stream analytics and Power BI together, working with Synapse and Purview, then labs on Databricks, right? Working with Spark and Databricks, creating Delta Lake in Databricks, working with SQL in Databricks, yes, Databricks and ADF integration, all of that, these labs, 22 different labs, which you can practice 10 times each, right? Apart from that, you also get a practice assessment for the exam DP203. And after that, once, see, these labs are guided labs. So that means that you will have instructions on the right hand side, which you need to follow and perform the lab. So these are all guided labs, right? Wherever you're stuck, you will have instructions on the right hand side that you can look at and follow the steps and complete and finish off the labs. That is there. Apart from this, there are some challenge labs also. All right. These challenge labs are individual challenges which will be given to you. There will be no guide over there. All right. Nobody will be guiding you as to how you're going to do them. Right. These labs can only be launched 3 times. Yes. And you have different challenge labs. All right. So you have challenge labs supporting module 2, run interactive queries in Azure Synapse Analytics serverless SQL pool. You have challenge lab on ingesting or loading data into a data warehouse. You have challenge labs on transforming with data with data factory and Synapse, yes, pipelines. Then lab on orchestrating data movement and transformation in Synapse pipeline. Yes, different labs are there. End-to-end security with Azure Synapse Analytics, real-time stream processing with Stream Analytics, create a stream processing solution with Event Hubs and Azure. Yes, so these different challenge labs you have. All right. So these challenge labs can only be launched 3 times each lab. All right. So you have challenge labs which are not guided, and you have these guided labs where you get 10 attempts each. So this is more than enough, more than sufficient hands-on practice that you need to have on the Azure environment without needing a subscription. All right. Azure subscription is expensive, especially for data engineering related workloads. All right. Data engineering services are very expensive. For example, uh, just an example, right? You have this data warehouse, right, in Synapse, a dedicated SQL pool, which is also called as a data warehouse in Synapse. It costs the most basic level of it, or let's say the most basic SKU of it, costs 100 rupees, INR 100 rupees per hour. All right. So with each lab, you get 2 hours of dedicated SQL pool. That is almost more than 200 rupees. And 10 attempts means that if you wanted to work on dedicated SQL pool for 20 hours, if you want to run dedicated SQL for 20 hours, the least amount of money that you're going to spend is 2000 rupees just for this single lab over here, lab number 8. I'm not even talking about other labs. With Spark, Delta Lake, with Databricks, those services are super expensive services. So if you get a subscription, if you want to work with your own subscription, it's going to take a lot of money. If you're thinking that you can use the free tier Azure services, all right, or not the free tier services, but the Azure free account, that only gives you a limited budget, all right? And it also gives you limited access to resources. Some of these data engineering resources you cannot create in the free account, all right? It just gives you very limited access to limited resources. So in that case, All right, these labs become very helpful for people who want real hands-on experience with Azure. All right, not just theoretical knowledge, but also hands-on experience to work with Azure resources in the Azure portal so that you have an idea, you have an experience of what Azure portal looks like. How do I have to perform a particular task in the portal itself? All of that clarity you will get through these labs.
Shreyas, do you cover project also?
Yes, so we'll be sharing a project with you. I will have a discussion with you where, we'll talk about the architecture that you want to implement for that project. We'll give you the problem statement, and then also we'll have a discussion on that so that you can add it to your CVs. So at least 3 or 4 projects we'll discuss.
On which domain you will provide the project?
Data engineering itself, solutions based on, data factory solutions or a solution on using Synapse with other services. So related to problem statements related to data engineering, DP203 that we are going to cover.
That's more like scenario-based question, right?
Yeah, scenario-based implementations where you will be, creating the entire infrastructure. We'll discuss the entire infrastructure also so that if you're questioned on how you did what you did, you have an end-to-end knowledge of which all services you used, how those services were built, which, let's say, SKU, basic, standard, premium, which SKU you used. Because based on this SKU, there are different features, which features of those services you used. All of that discussion we'll have. I'll just give
And
you a walkthrough of it.
how long this lab is available for us post this
The
classes?
lab, see, the lab will be given to you after we have started discussing on Synapse. All right, so that will come after, let's say, at least 1 or 2 weeks, 1.5 or 2 weeks. Suppose that once we have covered Synapse, I don't want to give you the labs now so that that because the labs are valid for 2 months, right? The lab validity is for 60 days. I don't want to give you the labs initially itself and then waste your time on the lab because initially you will not directly start with Synapse, right? We're covering basics of Azure. We'll move to data lake. We'll move to Azure storage. Then we'll move to Synapse, right? Once we've covered Synapse, then the labs will be given to you so that you can start practicing directly. And from the day the labs are given to you, the labs are valid for 60 days.
Okay. So will it extendable or not?
It is extendable. We can discuss.
Yeah.
So Shreyas, so the labs are provided by Microsoft
Yeah,
or
these are provided by Microsoft vendor, Scalable. Microsoft have an official partner, Scalable, that is providing these labs. These are the same labs which Microsoft is handing out in their partner trainings as well for any organization.
so that will give enough information to certified data engineering
Yeah,
certification.
that'll help you to gain enough hands-on experience to clear the certification. Yes,
Okay.
and to have a hands-on experience on the services also.
Okay. So after basic, so we will cover like Synapse or ADF.
Yeah, so we start with basics of Azure. Then we talk a lot in depth into storage because data lake is something which is heavily going to be used for data engineers. Yes, Azure storage is also something that you're going to use a lot. So once we are done with the storage, then we go to Synapse. Once we are done with Synapse, so in Synapse, there are basically 3 things that we have to cover, but initially we only cover 2. That is the serverless SQL pool and the dedicated SQL pool. Once we are done with both of them, we leave the Spark pool because Spark is something that we discuss towards the end, right? Where we discuss about Python, we learn Python, we talk about PySpark, yes, and the Spark architecture in general. And that is where we will do Spark pool from Synapse and Databricks because Databricks is also heavily relying on Spark and PySpark and creating these scripts. Now, post completion of Synapse, we go to ADF. Post completion of ADF, we go to Azure Event Hub and Stream Analytics. Then we go to Python and Spark, and then we go to Databricks. So Data Lake, Synapse, ADF, Stream Analytics, Event Hub, Databricks. All right.
Okay. Okay.
Shreyas, Is Databricks completely covered in this course?
Databricks is covered to an extent which is useful or which is necessary for the certification exam DB203. See, we can have an entire 40-hour session on just Databricks. So we have to cover only the relevant portion of it. Yes. So that it is the amount of knowledge on Databricks that is necessary to become a certified Azure data engineer. The syllabus that we are going to cover.
Okay, got it. Thank you.
It's not a dedicated Databricks training. We have to give weightage to all the services which are going to be essential for you to clear the exam, the certification exam from Microsoft.
And can you provide any Python material before we start this course? Because
yeah, we'll be sharing that. We'll be sharing.
Yeah.
I'll be sharing a YouTube tutorial with all of you, which you can access.
Okay.
And learn Python.
Okay. The complete course or the topics which are necessary for this, at least.
See, basics of Python is something that everybody should know. So just the basics of it, and then I have some documentations on PySpark as well that I'll be sharing, so that you can start learning about PySpark as to what it is. Right. Thank you for joining in, everyone.